Questions 11 through 20 on the 2020 Grade 10 AMC 10B. Miss Carr asks her students to read any 5 of the 10 books on a reading list. Harold randomly selects 5 books from the list, and Betty does the same. What is the probability that there are exactly 2 books that they both select? All right, probability question. As always, we've got a numerator and a denominator. The denominator, let's do first. That's the total number of cases. Well, Betty and Harold, they have to select 5 books from a list of 10. So the total number of ways they can do that is 10 choose 5 for both of them. And we're going to multiply them because we have to look at all the number of cases, all the number of combinations for Betty and for Harold. Now let's look at the numerator. The numerator is a little bit trickier in my opinion. It took me a while to figure this out, actually. For number 11, it took a lot longer than it should have. So let's go through this. First, we have to choose from the 10 books 2. And those 2 represent the 2 books that they both select. All right? So these are the common 2 books. Common 2 books. Okay, now those are already selected. Those 2 books are already taken care of. Now how many books we have left to select from? 8. Because 2 books have already been selected and we don't need to worry about those. From those 8 remaining books, Betty will choose 3. So this is Betty. Remember, she has to choose 5 in total, but we've already taken care of 2 of hers here. And then once Betty chooses 3 from those 8 books, there's 5 books remaining. And from those 5, Harold is going to choose 3. And he chooses 5 in total. He has 3 here, but then he has 2 here. Because remember, these 2 are common to both Betty and Harold. And this is the probability. So I'll let you do all the number crunching, figuring out what all of this is. When you do, and you bring it down to lowest terms, it's 25 over 63. Number 11, the answer is D. The decimal representation of 1 over 20 to the power of 20 consists of a string of zeros after the decimal point, followed by a 9 and then several more digits. How many zeros are there in that initial string of zeros after the decimal point? We have to do a little bit of approximation here. We're not allowed to use a calculator on these exams, so here we go. I'm going to concentrate just on that, of course. Nothing else to concentrate on. So I've got 20 to the power of 20. Now, 20 to the power of 20, we can break that up into 2 times 10, all to the power of 20. And, of course, that breaks up into 2 to the power of 20 times 10 to the power of 20. All right. Now, there's quite a few ways to approach this. I'll just sort of show one way. And it doesn't mean that this is the only way. You can do it any way you want, but keeping in mind you're not allowed to use a calculator. Otherwise, just do this in 5 seconds. Just plug that in, boom, off you go. Okay, so this is going to be 2 to the power of 10 squared, and then we just got this big number out here. Now, 2 to the power of 10 is a manageable number. Some of you even know that. It's actually just 1024. So that's pretty manageable. So I'm going to sort of deal with this number right here. Okay, so that number, 1024 squared, and I can expand that a little bit. That's one. You can either do the multiplication yourself, or you can just approximate it like this. And this is a little bit easier. It's just 1 million plus 48,000 and then 576, right? So this is obviously, it looks like it's less than 1,100,000. That's pretty decent, I think. And that 1,100,000 is basically 1.1 times 10 to the power 6. Okay, so that basically means that this 10 to 4 squared is less than 1.1 times 10 to the power 6. And it's greater than 1 million, which is 10 to the power 6. I'm just sort of getting a range for it. This obviously is greater than 1 million. This is 1 million right there, and then you're adding a couple more numbers. All right, so now that I have this, what do I do now? Well, flip it. Flip it, and when you do, you get in this in the denominator, and then of course you have to change the signs. 10 to the power 6 here. This is going to be 1 over 10 to the power 6, sorry. And then this is going to be 1 over 1.1 times 10 to the power 6, like that. Now, we want to bring this 2020 back somehow, and I think I can do that. All I have to do to bring it back is just multiply this guy by the 10 to the power of 20. So multiply through everything by 10 to the power 20. So this becomes the denominator, that is 10 to the power 6, 10 to the power 20. 1 over 1024 squared times 10 to the power 20. And then 1 over 1.1 times 10 to the power 6 times 10 to the power 20. And now we've got this, which is essentially our number, 20 to the power of 20. So we can just put that in there, 20 to the power of 20. And we have a range. Well, this is pretty straightforward. This is just 10 to the power of negative 26. This is also 10 to the power of negative 26, but we've got this 1 over 1.1, and that's approximately 0.9. Okay, now if this looks a little daunting, you think, well, I still don't know, I still can't figure this out. Let me give you a simple example. Let's say we had x, and that's got a very similar sort of range. It's between, let's make the number small, 10 to the negative 2, and then 0.9 times 10 to the negative 2. All right, well, 10 to the negative 2, you know that's just 0.01. And then this guy over here, 0.9 times 10 to the negative 2, that's going to be 0.009. And then if I asked you, how many zeros are there in x? Well, looking at this, it's less than this, and it's greater than that, so there's 2 zeros in x. So, by the same sort of philosophy, you can conclude that this has 26 zeros. So that's pretty much all they're getting at. And like I said, there's many ways of doing this. I just did it this way. You can do it in any way that you feel is fast and can be done without the use of a calculator, really. So number 12, that answer was 26, right? So that would make it D. Andy the ant lives on a coordinate plane and is currently at minus 20, 20 facing east. That is in the positive x direction. Andy moves 1 unit and then turns 90 degrees left. From there, Andy moves 2 units north and then he turns 90 degrees left. Then he moves 3 units west, again turns 90 degrees left. Andy continues this process, increasing his distance each time by 1 unit and always turning left. What is the location of the point at which Andy makes the 2020th left turn, the 2020th left turn? Okay, so let's just very quickly kind of illustrate what's happening. So he starts at some point, and they're giving that point as minus 2020. So I won't write it in because I don't think I'll have much space. But initially, he just goes east, and then he goes up by 2, and then he goes across by 3, and then goes down by 4. And then he goes that way by 5, and so on. So you kind of get the idea. And this is not going to be drawn to scale, but I just wanted to illustrate what's happening. So sort of this is what's happening. Okay. So let's label this. So this was 1 in terms of distance, this was 2, this was 3, this is 4, this is 5, and then so on. 6, 7, 8, 9, 10, and I think that's good enough. 11, 12, 13, you get the point. Now, what I'm interested in also are these corners, these points, because those are where he makes the turns. So this is the first turn, second turn, third turn, fourth turn, fifth turn, sixth, 7th, 8th, 9th, 10th, 11th, 12th, and 13th, and of course it just keeps on going. They want you to figure out the coordinates when he makes the 20/20th left turn. So eventually you're going to get a corner that instead of this 13, there'll be 20/20, and then what are the coordinates? Okay, I think I can do that. Let's talk about this in terms of these numbers. So those numbers 1, 2, 3 are where we make the turns. So we made a turn at 1, then 2, then 3. But I'm going to just look at these guys because I want to see if I can get a pattern. And I think I can, but I'm not 100% sure. So let's see. 1, the first turn, the 5th turn, the 9th turn, the 13th turn. Hopefully those 4 should be enough for me to see if I can get a pattern or not. Okay, so he starts at minus 20/20. So that is this point right here. That's minus 20/20. At 1, he's just going 1 to the right. So that coordinate would be minus 19 and then 20. Gotta be careful I don't make any mistakes here. Okay, then at the 5th one, I can do that. The x-coordinate, let's see here. He went back 3, but then he went forward 5. So he went 2, a net 2 in the right direction. So we have to add a 2 here. So that's going to be minus 17. Yeah. And then y direction to go from here to here. Let's see here. He went up 2, but he went down 4. So that means a net of 2 down. So minus 2. So this is going to be 18. All right. I don't see a pattern yet. Let's keep going. 9 is here. So 9... that means from 5, I had to go 7 that way and then 9 that way. So again, a plus 2 in the right direction. All right, so okay, I think I know what's going on here. We're going to get a plus 2 each time. And then for the y direction, going from 5 to 9, it went up 6, but it went down 8. So that's a net of 2 down. So minus 2. So I get to 16. Minus 15, 16. Okay, I'll just do one more. So now I want to go from 9 to 13 in the x direction. Let's see here. I went 11 that way and then 13 that way. So a net of 2 going right. So that's going to be minus 13. And then in the y direction, I went up 10, but I went down 12. So a net of 2 going down. So minus 2. And that brings me to plus 14. Okay. So I figured out the pattern. That it means that this basically just going up by 2 each time, and if you look at the x coordinate and if you look at the y coordinate, it's just subtracting 2 each time. Okay, so if I extrapolate this, I got to eventually get it all the way down to, what is it, 20/20th. Okay, 20/20th. All right. Now this has a very distinct pattern. It's going up by 4 every time. So that means if I take any of these numbers and subtract 1, it'll be divisible by 4. So if I extrapolate this ... eventually I'm going to get to 20/21. Because remember, this number, you have to subtract 1 to make it divisible by 4, like these numbers. And 20/21 is one of those numbers. Okay, so now what is my coordinate? Here and here for x and y. Each time you added 2, but how many 2's do I add? Well, that takes a little bit of, problem solving. Shouldn't be too bad. Let's see here. The strategy or the pattern, I think, is what you do is you take a number, subtract 1 from it, and then divide by 4. And that will give you how many 2's you had to add. So for example, the 13, that's right here. If I subtract 1, I get 12. If I divide by 4, that's 3. And indeed, I added the 2 3 times. So I hope that makes sense. A little bit of practice makes you able to get those kinds of things. So same thing with 2021. Take 2021, subtract 4 and subtract 1 and divide by 4, and you get 505. So that's how many 2's I have to add to this negative 19. So it would be negative 19 plus 505 times 2. And that's the number that goes in there. So that is 1010 minus 19. So that's 991. Okay, great. And then same sort of story here. Here we're subtracting 2's every time. So that number is going to be 20, this original number, minus 505 times 2. And that's 20 minus 1010, so that's minus 990. Great. Now we're very close to getting that 20/20th number. The 20/20th number. Okay, well, let's just say my diagram, I had drawn it all out until I got to 2021, and therefore this is 2020. Well, if I have the coordinates of 2021, all I have to do is just subtract, go in that direction to get the x-coordinate. And how much do I go in that direction? Well, 2021. Just like how this was 9 and 9 and this was 5 and 5, that's going to be 2021 and 2021. So I would have to take this x-coordinate and subtract from it 2021. So it would be 991 minus 2021 for the x-coordinate, and that is minus 1030. And then the y-coordinate doesn't change. The y-coordinate would be the same because we're not moving up or down. So that's minus 990. There you go. Let's see, where is that in the answer choices? 13 would be B. As shown in the figure below, 6 semicircles lie in the interior of a regular hexagon with side length 2 so that the diameters of the semicircles coincide with the sides of the hexagon. What is the area of the shaded region inside the hexagon but outside the semicircles? Now it helps to remember some formulas. Area of a hexagon is 3 root 3 over 2 times a squared, where a is the side length. In this case, the side length is 2. So that's going to be 3 root 3 times 2 squared over 2, and that is 6 root 3. So that's the area of the entire hexagon. Now the area of the shaded region, AS, that is basically going to be the area of the hexagon, which is 6 root 3, minus the area of the unshaded region. Unshaded region. Now, what is the unshaded region? That is what we have to figure out. And I will label this very carefully to sort of illustrate our strategy. The first thing we're going to do is draw a line from that point to that point. And then I'm going to connect those two like that. And as you can see, if you were to draw another red line there, that becomes a trapezoid. And because it's called a trapezoid, I'll just label that as T. So I'll just put a small t there. And if you do that throughout the diagram, you will create the same sort of trapezoids everywhere else. So we have how many trapezoids? 1, 2, 3, 4, 5, 6 of them. So we obviously have to subtract 6t from the area of the hexagon. But if you look closely at this diagram, the trapezoids are not the only part of the unshaded region. The unshaded region has also something small. You might have missed it. These guys right here. Those little guys, as you can see. And there's 6 of those. And each of those, I'll just call b, let's say. So if I can squeeze a b in here like that. So there's 6 of those, so I have to subtract those as well. Okay, so that is my strategy. If I can figure this out, I should be able to figure out the question. Now, there's one section right here that's a little bit outside the trapezoid. As you can see, that part right there. I'm going to call that A right there. So it was this part. Now, one semicircle, one full semicircle, which of course would be pi r squared divided by 2, is equal to, now pay attention, it's 2 of those a's, because there's an a on this side right here, and this is b, that little guy. So 2a plus b plus t. And therefore, pi, well, r is going to be just 1, because this whole thing is the diameter, which is 2. So that just becomes 1 squared, which is just 1. So pi over 2 minus 2a is equal to b plus t. And if you look over here, this is essentially 6b plus t. If we were to factor out a 6, it would be just t plus b here. So if I can figure out this, I can just sub it into there. So all I have to do now is figure out a. If I figure out a, I'm done with my question. Okay, and just to recap, here is a right here, this segment. All right, so I'm going to draw a here, this segment right here, just to use that part of the diagram because it's all symmetric. So that's a. Now I want to calculate a. So I wanted to blow this up a little bit. I basically just took this semicircle and blew it up because I think I might need a little bit more larger of a diagram. Okay, so again, let's put in our a and let's figure out what a is. So this is a right here. Okay, so how do I figure out a? That takes a little bit of thinking here. This is a very symmetric diagram and that's helpful. So what we can do is we can put a line from the center of that diameter to that point, and I think that should be good enough. And then I'll draw a line from that point down to the base like this to make it perpendicular like that. So that's a right angle. Okay, let's label this now. This is 1 because the whole length is 2, right? So the diameter is 2. So this is 1, and therefore this is 1. And therefore this from here to here is a half. So let's just label that. That is a half. And then from here to here is representing a radius of the circle or semicircle. And the radius is 1. And this is a right angle. So using Pythagoras, you can easily figure out this side, or some of you already know this is a 30, 60, 90 triangle. So that's going to be root 3 over 2. Now, even if you didn't know that and you just want to call it h, you can easily figure out h. It would be plus 1/2 squared is equal to 1 squared. So h squared would be 1 minus a quarter, which is 3 over 4, and therefore h would be root 3 over 2. All right. So now I still haven't figured out a, all this math here. How do we figure out a? Well, a is basically this segment right here, this pi segment. So pi minus this triangle. If I subtract the triangle, all I'm left with is a. So minus that triangle. So a, the pi segment, well, I need an angle. Well, it's a 30, 60, 90 triangle because h is equal to root 3 over 2. So I can easily label those angles. This is 60. And then this is 30. So the pi segment is 60 over 360 pi r squared. And then the triangle is 1/2 base times height. The base is from here to here, which is 1. And the height we just figured out was root 3 over 2. So this is, r is, what's r? R is 1. So this is just going to be pi over 6. And this is root 3 over 4. Okay, I'm set. I have a, I can figure out this now. So that's pi over 2 minus 2a. So 2a would be pi over 3. And be careful now, it will be plus root 3 over 2. And that's my b plus t. And therefore b plus t is going to be equal to 1/2 minus 1/3 is 1/6. So that's pi over 6 plus root 3 over 2. All right, I've got that. Sub it in. So that's 6 root 3 minus 6 times pi over 6 plus root 3 over 2. So that becomes 6 root 3 minus pi, and that's minus 3 root 3, and that is 3 root 3 minus pi. There we go. And like I said, there's several other strategies, but I like this sort of method of explaining it. 3 root 3 minus pi is D for number 14. Steve wrote the digits 1, 2, 3, 4, and 5 in order repeatedly from left to right, forming a list of 10,000 digits, beginning 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. He then erased every third digit from his list, that is, the third, sixth, and ninth digits from the left. He then erased every fourth digit from the resulting list, that is, the fourth, eighth, 12th digits from the left, in what remained, and then erased every fifth digit from what remained at that point. What is the sum of the three digits that were then in positions 2019, 2020, and 2021? First thing I'd like to do is write out a pretty decent sized string of these numbers, and then what we will do is we will go through the pattern. So here we go. And this keeps on going. Obviously, I don't have enough space to write it in one consecutive string, so I kind of put it on 3 different lines, but it's continuing. All right, so now let's do what the question is saying. First, he erased every third digit. So let's circle every third digit, and that way we can eliminate those. So very carefully, without making any mistake, let's circle every third digit. 1, 2, 3, 1, 2, 3, and so on. Okay, now let's do the next thing, which is he then erased every fourth digit of the resulting list. Okay, so all these numbers I circled, they're gone. Now what's left, I only look at those and circle or erase every fourth digit. Okay, so 1, 2, 3, 4, here we go. 1, 2, 3, 4. You notice I'm only doing it for the ones that are remaining. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so on. And then we're almost done. We now have to do the same thing now every fifth digit from what remained at that point. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3. And then it just keeps on going. Okay. And I sincerely hope that I have not made any mistakes. Now, what's left? Let's see what is left. Let's write out what's left. So 1, 2, 4, 2, 5, 3, 4, 1, 5, 2, 5. 1, 1, 2, 4, 2, 5, 3, 4, 1, 5, 2, 5, 1, 1, 2, 4, 2, 5, 3, 4. All right, a whole bunch of numbers. Does it make any sense? Well, look at this a little bit carefully. And do you see a repeating pattern? At first, you may not, but if you stare at it long enough, you will. And that repeating pattern is right here until there. That pattern repeats. 1, 2, 4, 2, 5, 3, 4, 1, 5, 2, 5, 1. Watch, it happens again. 1, 2, 4, 2, 5, 3, 4, 1, 5, 2, 5, 1. And then it happens again. 1, 2, 4, 2, 5, 3, 4. Well, it will happen again. I just didn't go any farther. And that is what? 12 numbers, right? So that pattern of 12 numbers just keeps repeating itself. And that pattern of 12 numbers is right here. So that works out really nicely. So we have to extrapolate that to get to the 2019th, 2020th, and 2021st Okay, I think I can do that. This is a pattern of 12. So that means that every multiple of 12 will be a 1. So this is the 24th and then so on, right? 36th, 48th. So I have to get sufficiently close to there for a multiple of 12. And after a little bit of thought, 2016. Because 2016 is a multiple of 12. It's actually 12 times 168. And that's going to be that 1. And then the pattern starts again. And that pattern is 1, 2, 4, 2, 5, 3, 4, 1, 5, 2, 5, 1. Okay, so this number, therefore, would be the 2017th number. This number would be the 2018th number. This number would be the 2019th number. This would be the 2020th number. And this would be the 2021 number. We are asked, first of all, what are those numbers? 4, 2, and 5. And we are asked to find the sum of those three digits. So 4 plus 2 plus 5 is 11. And therefore, the answer to this question, number 15, is D. Bella and Jen play the following game on a closed interval 0n of the real number line where n is a fixed integer greater than 4. They take turns playing, well, with Bella going first. At his first turn, Bella chooses any real number in the interval 0 to n. Thereafter, the player whose turn it is chooses a real number that is more than 1 unit away from all numbers previously chosen by either player. A player unable to choose such a number loses. Using optimal strategy, which player will win the game? All right, let's tackle this. I don't think the number n matters with regard to what it is, whether it's 5, whether it's 10, whether it's odd or even. So I'm thinking that C, D, and E are wrong because it won't matter if it's 1,000 or 100. Somebody will win and somebody will lose. So let's tackle this based on that assumption. So when we create a number line, and we have, let's say, 0 and n, and Bella goes first, right? Okay. And then to optimize the strategy, Bella will go and choose a number that's exactly half, kind of maximize his strategy of winning. So that's where he chooses. That's the first integer. And then the next one, of course, is Jen. And Jen will somewhere. We don't know where. So here's Jen. And let's just say that is a number x. And one thing we know for sure is that this interval right here has to be greater than 1 according to the rules of the question. And then Bella now has to go. And this interval right here is n minus x. So all Bella has to do is just plant or choose a number somewhere in there, and that will be sufficient to meet the criteria of the question. So basically, by symmetry, if Jen's move is possible, Bella's move is also possible. So, for example, this segment was greater than 1, and therefore this segment is also greater than 1, right here. And thus, the first player to be unable to make a move will always be Jen. And thus, she will lose. So basically, Jen will always be the first person to run out of a number to choose. Since if Jen's move is possible, then the very next move is Bella's, and that is also possible by symmetry. So, therefore, Jen will always lose, Bella will always win, and therefore the answer is A. There's a great book that goes through these kinds of problems, and I highly recommend it. And the book is called Winning Ways for Your Mathematical Plays. It's by Elwin Burley Camp, John Conway, and Richard Guy. And I'm sure you can get it on Amazon or any bookstore online. There are 10 people standing equally spaced around a circle. Each person knows exactly 3 of the other 9 people, the 2 people standing next to her or him, as well as the person directly across the circle. How many ways are there for the 10 people to split up into 5 pairs so that the members of each pair know each other? All right, so we are going to do this in a diagrammatic way, and here we go. So here's the diagram, and I'll walk you through it. The required pairings are sets of 5 of the 5 line segments. So as you can see, they've drawn a circle, what looks more like a Ferris wheel, but basically each of those 10 numbers would go around. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. And let's just say, give it one example. Person 2 knows 1 and 3 because those are the people next to him or her. And he also knows the person directly across, so he would know 7. And that's what those line segments represent, those red lines, those diagonals. So let's talk about them in terms of the diagonals. So let's say we have this scenario right here. And we use all 5 of these diagonals, 1, 2, 3, 4, and 5. All those diagonals are used. And that means we're using 5 diagonals, where each diagonal represents a pair. Well, that would basically mean that we would have 1 with 6, that's this diagonal. Then you'd have 2 with 7, and then 3 with 8, and then 4 with 9, and finally 5 with 10. And there's only one way of creating such a scenario. That's the scenario. Okay, so that's pretty straightforward. Now, how about 4 diagonals? 4 diagonals doesn't work, because if I use 1, 2, 3, 4, there's only 2 people left, 10 and 5, so they must go together. So 4 diagonals is basically like 5 diagonals. Now let's move to 3 diagonals, which is what this is illustrating. 1, 2, 3. And not only is it 3 diagonals, but it's also 3 diagonals in a very specific form. And you'll notice that the endpoints are consecutive. 1, 2, 3. 3 endpoints that are consecutive like that. So not only do you have 3 diagonals, you have 3 diagonals with endpoints that are consecutive. Otherwise, it doesn't work. Okay, that takes care of 1, 2, 3, 4, 5, 6 people. But what about the other 4? Well, then you have to use those 2, and we call those sides, I guess, like whatever you want to call them. So 3 diagonals and 2 sides. Okay, so if I were to label this 1, 2, 3, one such example would be the 2 and the 7, the 3 and the 8, the 4 and the 9. Those come from the diagonals. And then from the sides, you get 10 and 1 and 6 and 5. So that is one way of doing it. But you can choose this in different ways. There are 5 different ways of doing this scenario. The next scenario is the one next to it, obviously. And that one is as follows. Here we only have 1 diagonal. Because if you use 2 diagonals, it's not going to work. If you use 2 diagonals, you won't be able to pair up people as directed by the question stem. So 1 diagonal is next, as this is clearly illustrating there. So again, if you use that, you'll have to use 1, 2, 3, 4 sides as that diagram shows. And from this we can make the pairs. Let's label it first. And from those 5 possible diagonals, I chose 1, right? So how many ways are there to choose 1 from 5? 5 ways. So that's why there's 5 different ways that you can make this scenario. And then the final scenario, which is next to it, that essentially involves just all sides. So there's 0 diagonals here, just 5 sides. And 5 sides, I'll label them. And this is one way. And the other way would be the other guys. So for example, this and this and this. So it would essentially just be 2, 3, 4, 5, 6, 7, 8, 9, and 10 and 1. So as you can see, there's 2 of those. So now we just have to add 1, 5, 5, and 2. And when you do, you get 13. So number 17, the answer is C. An urn contains 1 red ball and 1 blue ball. A box of extra red and blue balls lies nearby. George performs the following operation 4 times. He draws a ball from the urn at random and then takes a ball of the same color from the box and returns those 2 matching balls to the urn. After the 4 iterations, the urn contains 6 balls. What is the probability that the urn contains 3 balls of each color? So we want a final result that's R, 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 blue, blue, blue. Now we initially started with just 1 R and 1 blue. So we have iteration 1, iteration 2, iteration 3, and iteration 4. And after the 4th iteration, we want this kind of scenario, 3R and 3B. Okay, that obviously means we've added 2 R's and we've added 2 blues. But that can be done in a few ways. You add an R, you add an R, you add a blue, you add a blue. That would do it. But there's also RB, RB. You see what I mean? Like the order can be reversed. RB, BR, that's another way. And then, of course, BRRB, BR, BR, and finally the last one would be BBRR. So there's 6 different ways of getting to this possible end result. So let's just calculate the probability for one. And I'm pretty sure that the probabilities are the same for each of these. So let's see what it is. Okay. Initially, there's 1 R and 1 blue. I'm concentrating on this guy. So I want the next one to be an R. So the probability that I pick an R is a half. And when I do, it becomes R, R, and B. Now again, the next one I want it to be an R. So the probability that I pick an R here is 2 out of 3. So 2 out of 3 goes there. Now I have an R, 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 and a B. Now I have to pick a B. So the probability of getting a B here is 1 out of 4. And then finally, I've got to pick another B. So first let's just write down what it becomes, R, 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 B, B. And I've got to pick a B, and I do that here. Of those 5, so 2 out of 5. And then I end up with my desired result. So now I've got to combine these probabilities by multiplying these probabilities. So that's going to be 1 over 2 times 2 over 3 times 1 over 4 times 2 over 5. And that is 1 over 30. So the probability of this is 1 over 30. And I'll let you do all these other ones because it's going to be exactly the same. The good news is they're also all 1 over 30. So that makes it very nice. All you have to do now is add up these guys. So plus, 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 plus. And when you do, you get, what is that, 6 over 30. And 6 over 30 in lowest terms is 1 over 5. So number 18, the answer is B. In a certain card game, a player is dealt a hand of 10 cards from a deck of 52 distinct cards. The number of distinct unordered hands that can be dealt to the player can be written as 1, 5, 8, and so on. What is the digit A? Well, with a calculator, this would be a piece of cake because from 52 cards, you choose 10. And that's it. That's pretty much the question. But the reason it's number 19 and therefore more difficult is because you're not allowed to use a calculator. Okay. All right, so we got to do this manually. 52 factorial, 52 minus 10 factorial, which is 42 factorial, or over 10 factorial. Okay, so let's write this out. 52, 51, 50, and so on. And on the bottom, it's basically just 10 factorial, so 10, 9, 8, and so on. So now my goal is to see what I can cancel out, and then hopefully I'll get it down to a little bit less of a number. So let's see here. The 10 and the 5 is 50, so that cancels with that. The 8 and the 6 is a 48, so that cancels with that. And now I don't think I'll be able to cancel anything more, but I might be able to reduce some stuff. So, for example, the 7 and the 49, that cancels to just leave a 7. And then the 9 and the 45, that cancels to just leave a 5. The 3 and the 51, that's 17. And then, let's see here, what else? The 2, well, that can probably cancel with any of these. For example, that can be just a 26. And then the 4 we can use to cancel that 44 into an 11. So all I'm left with is 26 times 17 times 7 times 47 times 46 times 5 times 11 times 43. It's still a very big number. But there's a good news here that all we really care about is getting sort of this second last number. Now, the last number is a 0, and I see why, because we can take out a 10. For example, this 26 is 2 times 13, and the rest is the same. And this 2 and this 5 combine to give a 10. So because there's a 10, that means the last digit is a 0. So that's why we have a 0 at the very end, and then the rest is going to be just what's remaining. So now all I have to do is pretty much just look at the remaining numbers, which are these guys, and then just look at what will be the units digit of that. Because if this is this big long 1, 5, 8, A00, A4, A0, if I divide through by 10, then I'll just be left with 158, A00, A44, AA. And it would be just leaving what's on this side without the 10. So now it really just boils down to finding the units digit. And to get the units digit, I just have to look at the units digit of these guys, which is 3, 7, 7, 7, 6, 1, and 3. So it's a little bit more digestible there. And this can be done without too much pain. And when you do, you get 18522. So the units digit is 2 here. The units digit must be 2 there. So A is equal to 2. Therefore, number 19, the answer is A. Let B be the right rectangular prism box with edges 1, 3, 4, together with its interior. For real r greater than or equal to 0, let S at R be the set of points in three-dimensional space that lie within a distance r of some point in B. The volume of SR can be expressed as AR cubed plus BR squared plus CR plus D. What is BC over AD? Okay, so we got a big one here. So first, let's just draw that box. All right, so that means that if we have some point in B, where B is that box, then we want to be able to figure out the volume of all the points that are within a distance of r. So the first thing is, of course, most likely it's going to be the entire box that will be part of our volume. And this expression actually a little bit hints at that, because you have this in terms of r, this in terms of r, this in terms of r, and this is not in terms of r. So that D most likely represents that prism, which is independent of r, and its volume is just 4 times 3 times 1, which is of course just 12. So I have a strong suspicion that the D is 12, but we'll figure that out later. Okay, so we got one part. I think there's going to be 4 parts to this since there's 4 terms. Okay, so the next one would be just these extensions of the sides. So if I have a point, let's say right here on a corner or on a side, it could also be outside of that prism. So that would have to extend a length of r. So let's draw those in. So something like that. And as you can see, these dimensions, this is going to be r right here. And this is, of course, just 3. And this is 1. So this is a r times 3 times 1 prism. And that also has to be part of our overall volume. So that is 3r. But there's going to be 2 of them, right? There's going to be another one on the other side. And since there's 2 of them, 1 on each side, we have to multiply this by 2. So that gives me 6r. And the same story holds that we're going to have 1 on the bottom and 1 on the top. And those dimensions will be, let's see here, that would be a 4 by 1 by r, because this is r. So 4 by 1 by r is just 4r, and then there's 2 of them, so that's 8r. And then there's going to be another one coming in front. I'm not going to draw that in, it'll make the diagram too messy. Well, I'll attempt to draw it in. Let's see. So there we go. I'll just draw the one that comes out in front. And that one would have dimensions. This is r. So it would be r times 4 times 3, which is 12r. And since there's 2 of them, there would be one going behind. That's going to be 24r. So this added up is 38r. And I'm pretty confident that represents CR. So this was 12, and that I think is my D. This 38R is my CR. Okay, now let's move forward. We got 2 more. How do we get those? BR squared, BR squared. That squared makes me think, obviously, there's some sort of a circle involved, and this cubed makes me think that's a sphere. All right. Okay, I think I got it. The squared part, that's going to be like this. So as you can see, that is a quarter of a cylinder. So if we had a point here, it would be within r of that. So we got quarter of a cylinder, and there's going to be 4 cylinders, right? There's going to be one down here. As you can see, like that. There's going to be one over here, and there's going to be one over here, like that. So based on that, 4 quarter cylinders is essentially just 1 full cylinder, but each of those cylinders have slightly different dimensions though, and the area is pi r squared times height for those 4 quarter cylinders combined together is 1 full cylinder. Now for the ones I drew in, that one, the height is, let's see, from here to here, and that, according to this diagram, is 1. So this is just going to be pi r squared. And then similarly, there's going to be another 4 quarter cylinders, And like, for example, this one right here. Do you see that? Very similarly, those 4 would add up to give one full cylinder, which again is pi r squared times height. And in this case, that height is from here to here, which is 4. So that's going to be 4 pi r squared. And then there's going to be another set of 4, and that will be here, right there. Hope you can see that. And that, again, 4 quarter cylinders will give me one full, and in those ones, the height is from there to there, which is 3. So 3 pi r squared. So totaling these, we get 8 pi r squared. And that, I'm confident, is that br squared. Okay, one final left. And judging from this diagram, I think I realize that it's going to be here. This, it's very difficult to draw, but when kind of pulled out, becomes a sphere. And there's going to be one on each of those corners. And there's 8 corners, right? 1, 2, 3, 4 on top, and then 4 on the bottom. And so therefore, each of those is an eighth of a sphere. So that is conceptually a little difficult to understand, but that is an eighth of a sphere. And since there's 8 of them, 8 times 1/8 is 1, so it would become one full sphere. And the area of a sphere is 4/3 pi r cubed. And therefore, that's all I need to do there. So therefore, that is my AR cubed. All right, so let's combine it. We have to figure out BC over AD, right? So B looks like it's 4/3 pi from up here. Or sorry, B is here. B is 8 pi right there. You gotta be careful there. C, now let's see. C is here. C is 38. So that's 38. And then A, well, A is here. The A is 4/3 pi. And then finally D, well, D is 12. Okay, great. So the pi's cancel, and all I'm left with is 8 times 38. And that's 304. And then 4/3 times 12 is 16. And then finally 304 divided by 16 is 19. So that was a very difficult question in my opinion. I really wish they gave us a diagram, but they didn't. So anyhow, number 20 is B.